or transient or all are recurrent. Why is this? Can somebody tell me what is the proof and why is this true?
So it is just by the definition that we have given the definition of the recurrent
Yeah.
only, sir. Because
So, for
recurrent is
example, if you have a class, right, that means the two nodes can communicate with each other. That's what it means, right? So, suppose one of them is transient. What does that mean? Or let's look at recurrent. If one of them is recurrent, what does that mean?
it
What is the
means
definition of recurrent?
it means if it
If it
is
can communicate with I,
with,
then it can
yeah,
communicate with,
then I should also communicate with this also.
right? So now,
Yeah.
so suppose I can communicate with J, then J should be able to
Hello, sir.
communicate with I, right? Yes.
Sir, in the graph that you draw above, preview
Aha.
above,
Yeah, yeah, yeah.
sir,
Okay, go ahead.
in this 0 and 2 are like recurrent.
No, not really,
That
right?
is
So that's something that we made a mistake, right? Now, let's go by this definition. So you're right. That's what I was also about to say. See, what can you say about 3 and 4? Hmm?
mm,
It belongs to one class, right? That is very clear. Now,
yes.
3 and 4 are, is it recurrent by definition? See, if I 3 can communicate with 4, implies 4 can communicate with 3. So they can go back and forth, right?
Yes, sir.
Right?
Yes,
Is
sir.
that clear?
Yes, sir.
Okay. So now these two are definitely recurrent, right? Now I'm saying this is transient. Okay. What does that mean? Intuitively, that means you won't visit this state infinitely often. If you allow the Markov chain to run forever, you won't visit again and again and again. Okay. Why? There is some non-zero chance that at some point in time you will enter 3, and after you enter, it's a no point of no return, right? You just go to 3 and you go back and forth from 3 to 4, 3 and 4, right? So this is transient. So what can you say about this guy now? Huh?
Then if it moves to one, then there may be a chance
Just,
that one moves
yeah,
to another and doesn't come
it
back.
to be recurrent. If I communicate with J, implies J come for every J in S. That's correct. So I think we missed that. Can 0 communicate with 3? Yes, right? In two
Yes, sir. Yeah.
steps with a probability of at least 1 by 8. Well, will 3 can communicate with 0? Not really.
Mm.
Therefore, this is also transient, right? So what can you say about 2? 2 can communicate with 3 with probability of at least 1 by 8, but 3 cannot communicate. So this will also be transient. So all the states within this communicating class is transient. Okay, so I take back my words, which I said, where I said 0 and 2 are recurrent. It's not really recurrent, right? All of them are transient, and 3 and 4 are recurrent. Is that fine now?
Yes,
Yes,
sir.
sir.
Yeah.
Ayush?
Yes, sir.
Okay. So now, suppose you have a state to be recurrent in. So let me draw a picture. So you have some set of states here, okay, and some set of states here, okay. Now, if one of them is recurrent, what does that mean? If this guy can communicate with anyone else, that guy should also be able to communicate, right? So now, suppose this guy can communicate with this, right? By definition, because it belongs to the same class, right? That means this also will be able to communicate with this guy, right? Do you agree? And this node can communicate with this node also, and likewise, because it's communicating class, right? So now, by this diagram, I can clearly see that this node can communicate with this node and vice versa, because there is this path which goes from here to here, and there is this path coming back, right? Do you agree? So that
Yes.
means all of them will turn out to be recurrent. Do you
Hello,
agree?
sir.
Yes.
Sir, can there be a transient relation be present in a class for a state? I mean,
What do you mean by that?
I mean, see, the left side there is a class. Okay, you have drawn just this a
So
class.
you're basically saying if I have a Markov chain, can I break this into set of all transient and set of all recurrent? Is that what you're saying?
Sir, not exactly, sir. I am saying, sir, like the left class that you have drawn. Sir,
Okay.
can there be a state from where there is that is transient? I mean, within that class, but that is not recurrent. Sir, because in the previous diagram, what you have drawn, from 1 we can move to 3, but that were two different classes.
Yes. Yes.
So I am saying, sir, can there be a state within the left class that is transient to some other state within that class, but not recurrent?
No, there is no, the notion of transient is not with respect to something. It's a universal truth. A node is transient or not. That's all. Right? So when do you say a transient? If a node can communicate with something, if a node can reach some other node, I communicates with J, then J should be also be able to communicate with I. Okay? It should not be one-way path. That's what it says. It's always two-way paths that you should have. Okay, then we say that it's a recurrent, right? Otherwise, it's transient. See, the issue with 0, 1, 2 here is that there is a one-way path to 3, not the two-way path, right? That's the problem. See, all that we need to identify is 1, right? 1 has a one-way path to 3. And since 1 can communicate with 2 and 0, all of them have one-way path. That's all. That proves everything, right?
Yes, sir. Yes, sir.
Okay. Can you formally write this proof? Okay. Is that fine? So how do you prove that? So what is the proof technique? So you assume that one of the node is transient. So I have to prove that all the nodes in the communicating class is transient, right? Now you arrive with a contradiction. Suppose not. Okay, so there is one special node, let's say this node, which is not transient. Okay, that means it's recurrent. So what